Howdy and welcome back. So, a little bit of review before we get too far into this. What exactly is a class? Well, we're going to see here that it's going to be common for us to refer to the representation, so the data members that our type houses in the operation or member functions for our user-defined type as its attributes and behaviors, respectively. For now, let's only focus on the attributes of our color class. We're not going to prescribe any behaviors for it just yet. We're going to introduce the color class as having storing three integer values. That's how we will represent our colors, would be to assign various values to these components to dictate, say, what it means for a color to be Aggie maroon versus what, say, an object storing maize may look like. At this point, simply think of a class as a template from which objects of that class type can be created from. So it's a blueprint. We haven't actually created a structure yet. However, when we create an object of this type, kind of that building or whatever will actually be created. And what we'll see here is that through the attributes, we can make things that look very similar to one another in terms of their their actual underlying structure. However, their underlying state could be different. For instance, they'd all have R, G, and B components. However, the values they take on will inevitably be, in most cases, different. So this moves, okay, we have this blueprint, this class. Well, what the heck say object? Well, an object is going to be an instance of the user-defined type from which it was instantiated. So we have our blueprint, and from that, we could create some objects. So actually physically building something from that blueprint. So if we wanted to create, say, Aggie maroon, we could create a color, we could name it something, and then we could go ahead and populate the RG and B components. Notice we haven't talked about any behaviors that would allow us to do that at this point. But again, what we're trying to point out here is that once we actually instantiate a color, an object from our color blueprint, the actual underlying state or representation from one object of that type can look very different than another, such as maize. So the values within the data members are going to represent a respective object's current state. It is the attributes of an object that is going to differentiate one object from another of the same type. Accordingly, each color object instance will have its own memory space to store its own set of data members. So notice here, if we were to create a color object storing Aggie maroon, that would have its own space all located in memory to house those data members. Likewise, if we wanted to create maize, it would receive its own allocation of memory where we could store the state of the RGB components for that object. The behaviors, which we'll get into here soon, will detail what objects of a respective class type can do. These are member functions, and they are not going to be stored separately for each instance of a class. So while the actual state of, say, our objects will have memory allocated, they will all share a single implementation of the member functions. We'll see how that works a little bit later, but essentially an implicit instance argument will be passed to the member function when it is invoked on a specific color object. And that argument will essentially communicate to the function which object invoked it and then be able to go out and access the actual representation of the object who invoked it. Each color object will have the same behaviors as all the other color typed objects. So it's not like the maize color will be able to do anything different than the Aggie maroon color. They will all have the same behaviors, but where we get to kind of see the power of this is that when we understand that the underlying state is going to obviously dictate the outcome of the application of those behaviors to a respective object.